Congratulations. 8-7 practice and problem solving is your last assignment this year. Wow, I wish I was there to cheer you on with this, but thank you for all your hard work throughout the whole year. This is just been a crazy year, right? But you know what? It's been fun too. I think we've learned so much from just doing topic 8 and the end of topic 7 online like this. I think there's a lot of learning for both me and you that has happened because of it. And you saw it to the end. And we're going to get these 4 questions done. And then you do the quiz and we'll be done. And that's it. So, wow. Here we go. We have what are the mean and the median? Okay, so I went ahead and plotted these in order from least to greatest behind me. And then you add up all these numbers and divide by however many there are. There are 9. And I got, I think, 12. And then the median, I didn't do that one yet. We go like this. And 10. It ends up with one number because 9 is an odd data set, which you guys should be very solid on so far. Okay. Now we're going to do a box plot of it. Okay, so in order to do a box plot, we got to find the 5 boundary values, guys. The 5 boundary values. So we have the minimum, the first quartile, the median, the third quartile, and the maximum. All right, so the minimum is 5. The maximum is 26. The median is 10. Now look, if the median's 10, I come to here, 2 numbers, add them up, divide by 2. I get 7 for the first quartile. And here, I get 12 and 23. So I'm going to add up 12 plus 23. And I get 35. 35 divided by 2 is, I think, 17.5. Okay. So now I have the 5 boundary values and we can continue. So let's see. 5 is the minimum. So it could be that one. It could be that one. Oh, darn. We didn't check any of them off. The maximum is 26. So it's not A in my case. There's 26, 26, 26. So we narrowed it down to 3 now. I like checking out the median next, which is 10 for me. Nope. So we know it's not A or B. So it could be this one. And it's not this one. They're saying the median is the first quartile. So just to be complete, I think it's D, but just to be complete, 7 is the first quartile. That looks like 7, right, guys? And 17.5, yeah. All right, so there's our box plot there. And describe the overall shape of the data. It looks like there's 50% of the data there, and there's 50% of the data spread out there. 75% of the data lies between 5 and 17.5. Hold on a second. All right, sorry, someone was at the door. So describe the overall shape of the data. Most of the data are grouped between 5 and 12 is what I put now. Let's see, 5. And then I was like 12, but I think they're saying 12 because 12 is the mean. So if you look here at the actual numbers, most of the data is between 5, and you can see once it goes to 12 here, there's a big gap. There's a big gap that then leads to the 23 and the 26. So that's why I said that. The data are more spread out to the right. So you can see the data is more spread out to the right. There is a gap in the data between 12 and 23. Yeah, from 12 to 23, there's a big gap that this doesn't really show well, but the dot plot does show well. So make a generalization about the data distribution. The typical player scored how many points? The typical player scored how many points? I'm either going to say 10 or 12. I think 10 better represents what the typical player did. Because if I were to say 12, it's really these outliers, these two kids that really brought the mean up. But I'd say most people scored around 7, around 10. I'm going to put 10. Let's see if 10 works. Now, I could be wrong here because I'm not sure what they're going for with that. Most of the data clusters between 5 and 12. Only a few players scored 20 or more points. That's true. All right. Okay. Whew. So as you can see, the median was the best measure of center in this case because these two are kind of considered outliers. All right. Moving right along. And let's see what this one says. A doctor asked 15 people how many hours they spent exercising each week. The dot plot displays the data. What do any clusters and gaps in the dot plot tell you about the exercise habits of these people? So most people exercise. So if you look here, most people are exercising like 1 hour a week. And there's just a couple there, but not enough to make a difference. And then there's some of these hardcore folks, like 7 people exercise 8 or 9 hours a week. So I'd say most people exercise 0 to 1 hours or 8 to 9. Let's see if that is there. Okay, so either fewer than 2 hours. Yeah, fewer than 2 does not include 2. Or more than 7. More than 7 does not include 7. Yeah, so that one. That's an interesting graph. So we're learning how to interpret these graphs here, which is a good skill. You don't want to be swayed by the data by looking at graphs. You want to be able to tell what they're saying. Let's take a look. So we don't have to do the writing part, but describe the pattern of the dot plot. Looks like it's all clustered around here from 0 to 5. So let's see. Then most of the distances are, I'd say 5 and under. It doesn't really have 5 or under, but it does have fewer than 5. Now, I don't know why they didn't say 5 or under, or fewer than 6, but I guess they're not counting 2. Let's see if that's right, though. Yeah, it is right, because there's this big cluster here, then there's a gap, and then there's a few out here. And our last problem, guys, this is our very last problem of the 2019-2020 school year. So proud of all of you. Thanks for watching these videos. I sure have fun making these videos for you. And here we go. This is it, guys, our last problem. And then we have a weekly STEM project, which I'm going to give you 2 weeks to do. Which statement about this data distribution is not true? Which one is not true? Okay. So before I even look, I'm just going to take a peek at the graph. It looks like there's a big cluster in this kind of general area, even over there. I wish it was more defined, like more shaped, but we'll go with it. So the data cluster from 2 to 10. Okay, maybe. The data distribution is symmetrical. Symmetrical means like if you fold it in half like a butterfly. That's what I mean by shape. I wish it showed that. The interquartile range is 5. Oh man, am I going to have to find the interquartile range? The median is the preferable measure of center. Wow. So it's not a symmetrical data shape because this would have to be more in the middle. So not B. The interquartile range is 5. Could be that. But I'd say this is a very true statement. The data does cluster from 2 to 10. Let's go with that one. Oh, man. Okay. So in this case, even though this is a true statement, I guess it clusters more from 2 to 4. We are going to have to find the interquartile range. All right, so here we go. Let's do it. We have 2, and then what is that? 3, 3, 3. So 2, 3, 3, 3, and then a 4. And then we have a 6, 7, 8, 6, 7, 8, and a 10 and a 16. Okay. Finding the median. Comes between two numbers, so the median is 5. Median equals 5. Minimum is 2. Maximum is 16. First quartile, third quartile. All right, let's see. First quartile is 3. Third quartile is 8. Third quartile minus first quartile, 8 minus 3 is 5. So the interquartile range is 5. Is B. How is the distribution? Guys, what? Does this say which one is not right? Oh my goodness, you are all probably laughing at me. Which one is not true? Which one is not true, Mr. Jacobs? Wow, should I redo this? No, I'll keep it. I'll let you see me mess up. That's just a reading mistake, Mr. Jacobs. The data is not symmetrical, but there is a cluster here. The interquartile range is 5, and the median, I suppose, would be the best measure of center here because the mean would get pulled down too much. Yeah, so let's try it again. Oh, I guess you get to see me miss one, right? And I guess we get to see some different shapes of the data set. So which one is not true? Which one is not true? Well, I get to spend more time with you guys. I get to spend more time. So there's a cluster from 3 to 9. That is true. So not that one. The data is symmetrical. No, it's not. Oh, it's not. So the data is not symmetrical. The median is the preferred measure of center, the interquartile range. I'm going to say that does not look symmetrical to me, guys. We have done it. Hallelujah. Oh, I'm going to miss you guys next year. If you want me to continue doing 7th grade EnVision assignments so you and I can hang out while we do your homework, I would love to do that if you're interested. This is Jason Jacobs signing off with our last EnVision assignment of 6th grade. Proud of all of you. Goodbye and good night. That sounded way dramatic. All right, I'll see you later.